So hello everyone, this video is to complement the installation guide video, but in this part I will explain you how to navigate through the code for IDIT-SDN. So let's start in the applications folder. Just to remind, all these folders are also in the IT-SDN framework. So in this case, we will explain the parts that are related to the IDIT-SDN part. This means to the US detection and simulation. So let's start with the applications folder. Here you can find the make files that you have that you need to configure according to your simulation and to the scenario that you would like to simulate. So here you can set the flags for distributed detection, the flags for centralized detection, and also the monitoring time. This is the time that you will set for the controller to take samples of the metrics that it will analyze. You have something similar in the enable node, makefile enable node, but in this case, you will also have the sampling time. Okay, the sampling time is the period that we configure for every node to take samples of the metrics that it will analyze for anomaly detection. Also, you can set here the attack period, but this works only for attack FDFF and attack 2. Okay, then the intrusion node is something similar, but for attack 3. This is separated for because we usually have some other flags that are specifically for this case. Here you have the enable node and the attack FDFF code that you can check and modify according to your necessities. And also you here can access the management sync, the sync node, and the controller node code. That in the case of the controller node, you have to remember that this is the gateway between the WSN and the controller server. Then the other important part, well, there are four important parts, is the controller server. Here you have the security module code. Here is all the implementation of the intrusion detection that runs in the controller server. So here the first part is for the distributed detection. This means that here you will receive all the alarms from all the sensor nodes or the network devices to determine the suspects and to determine the attackers. Then here you have the centralized detection. After this, start all the code for the anomaly detection in the centralized metrics. So here, this is the code for the time series constructions. Then you have all the math that you require to detect an anomaly. And then you have here the global attack identifier. This means to determine if this is an FDFF attack or an FNI attack. The critical value that here you can set the parameters to determine the critical value. And for lastly, the security print time series. This is to print the time series so you can monitor the values of this time series. Okay. Another important thing is to here in the SDN metrics calculation. There is one parameter that you have to modify, and this is, for example, in the case of nodes that, well, you have to set here the number of data packets that you expect to receive per minute. Okay, so in the case of 225 nodes, for example, if you're sending 100 node, if you're sending one packet per minute, and you have 222 nodes, sending packets to the sync node. So this is the number that you will expect. But for example, if you have 36 nodes and 33 of these nodes are generating data, 1 packet per minute, you will have to put it here 36. Sorry, 33. Okay, so this is something that you have to check every time that you will initiate a simulation. Then you can go to SDN common, where you will find the code that runs on every node. Here, this is the code where you can check all the functions and all the algorithm to detect anomalies on every sensor node. Okay, so in this case, this was implemented as a process thread, which name is security node process. And this process, we have here one function to initiate the process. So you can find where this process, well, sorry, you can then find where this function is summoned to initiate the security process. Okay. Then you have the simulation folder. Here you have some examples. The path simulation, you have to configure this according to your path. And also you can configure here the simulation parameters. Here you can set the number of simulations that you will that you need to run, the number of simulations in parallel, and in this case, well, 36, because this is the simulation that we have implemented, and the time that you want to run the simulation. Okay, typo. Okay, so let me show you what you will see when you have when you finish with some simulations. In this case, I'm gonna show you a simulation that I did for 36 nodes during 5 hours, when after 210 minutes, the attack start, and you will see how the nodes report when they detect an anomaly and when the controller server report that it detected an anomaly. We will start with the information on every sensor node. So for this, let's go to IDIT-SDN, simulation, results. Let me open this with this program that I think is very useful for logs. So here, this is the mode output of the Kuja simulator. Since we are simulating an FDFF attack, you can find here, using the word false, you can find where the attack start, the flooding, or where they start to fool its neighbors. So this is these are the entries or the prints when every attacker execute the attack. Okay, so then you can also check if any node detected something strange, detected an anomaly. So if you put here in the filter, well, in the text, CP detected, you will see all the results of nodes that detected an attack. So here you have the number. This number is in this number, sorry, is in decimal, if I'm not wrong. Yeah. The node number 5 detected an anomaly in the sample 222. So how you know that the detection was after the attackers start the attack? So you can put it here, and or let me see, yeah, and also type the word false. So the first that you will see is when the nodes, the attackers are executing the attack. If you start to going down, you will see that after some attacks, well, after the attacker executed send these data packets to fool its neighbors, you will see that the node number 6 detected an anomaly in the 220. So this means that it's probably this detection was caused by the attack of the FDFF attack. So this is important to observe. Then, well, these nodes will send an alarm to the controller server that you will and you can check. So let's go to the controller, and in the controller, you will see that suspect. Let me see this. Okay, first suspect. Here you have the list of suspects. Okay. The list of suspects, if you, in this case, this word is in hexadecimal. So the 28, 2A, and 29 are the 40, 41, and 42, which are the nodes that we program as attackers. So here you have these nodes reported as suspects, and also you can have the block list. Let me see. It is capitalized in uppercase. The block list, in the block list, you will have the nodes that were identified as attackers. So this is something that maybe you will see strange, but the controller node is in the attackers list. This is a policy that you can establish to ignore the controller. This is because the controller is sending too many control packets that some nodes identify as a strange behavior, so they report it. But this is something that maybe you can include in your policy to ignore or not this behavior. So you can go here, you can continue checking these results, and you will see that now 2A was included in the attacker list. And then let me see, the 29 is included in the attacker list. So this is the result that you will see in the attacker list, that, well, the 3 nodes that we program as attackers, they were detected as attackers. Also, let me see if you have here. Decentralized detector also detected something strange. It was after the nodes detected the attack, because this is in the 238 sample. So this has sense because this is not specifically an aggressive attack. So it is normal that the attack was initially detected by the neighbors of the attacker and then by the controller, because the speed of the attack is not too high. But here you can see that the controller detected the attack in the sample 238, and it was identified as an FDFF attack in this case. Okay, so this is the results that we expect you can have using this framework, but also you can modify the code to have some other results that maybe will be useful for you. I think that with this guide, it will be easier to use this framework, and I hope it will be useful for your research. Any question that you have, don't hesitate to contact me, and so see you later.